Our world is a single breathing system, every part connected to every other. The air over Africa will one day touch the Himalayas. Pacific water may fall as Amazon rain. Weather seems local, but it's part of a global puzzle. Weather is a story told across the planet, a story of constant movement and change. A storm in one region can ripple across continents. The atmosphere has no borders. It's a shared blanket covering us all. Today, we'll explore a single day, December 3rd, 2025, across Europe. A simple weather event can spark a chain reaction felt globally. It's a lesson in unity, written in the clouds and carried on the wind. Let's begin our journey. On December 3rd, 2025, Europe's weather is a study in contrasts. Storm Freya lashes the British Isles and northwest France with wind and rain, while ferries are cancelled and coastal towns brace for flooding. Further east, high pressure brings calm, frosty days to Poland, Hungary, and Romania, fields and rooftops dusted with frost. In the south, Italy and Greece enjoy mild sunny weather, with lively outdoor cafes and autumnal air. Scandinavia is deep in winter's grip, heavy snow and intense cold. Europe's weather is a snapshot of global patterns, each region connected by vast invisible forces. To see how Europe's weather connects to the world, look high above, at the jet stream. This fast-moving river of air, 10 to 15 kilometers up, flows west to east, circling the globe. It meanders in waves, shaping weather below. The jet stream separates Arctic cold from tropical warmth and powers our weather systems. On December 3rd, the jet stream over Europe is especially wavy. A deep trough over the eastern Atlantic lets Arctic air plunge south, fueling Storm Freya. The jet stream spins the storm, lifting air to create clouds and rain. East of the trough, a ridge brings sinking, warming air, explaining Eastern Europe's calm, clear weather. The position of these waves, troughs and ridges, decides who gets storms and who gets sun. The jet stream is the master puppeteer. Weather systems dance to its tune. These waves move, drifting west to east. The trough over the UK will soon move toward continental Europe, bringing storms to Germany and Poland. The ridge will slide east, perhaps over Russia. The jet stream is a continuous global system. A wave starting over the Pacific can cross North America, the Atlantic, and shape Europe's weather. It's a truly global connection. Another force linking Europe's weather to the world is the North Atlantic Oscillation, or NAO, a giant atmospheric seesaw. On one end, low pressure near Iceland. On the other, high pressure near the Azores. The pressure difference drives winds across the Atlantic, shaping winter weather in Europe and North America. On December 3rd, the NAO is strongly positive. Big pressure difference, strong westerly winds. Storms like Freya barrel into northwestern Europe, bringing wet, mild winters. Southern Europe, meanwhile, is drier as the storm track shifts north. The same winds pull cold, dry air into Canada and the eastern US. A stormy day in Scotland links to a cold day in New York. If the NAO were negative, weak winds would let Arctic air spill into Europe, bringing snow to London and Paris, while the US might be milder. The NAO is a perfect example of how oceanic pressure patterns dictate weather for millions. One balance point over the Atlantic can tip the scales for two continents. Let's follow Storm Freya's journey. On December 3rd, it batters Ireland and the UK. Carried by the jet stream, it moves east. By December 4th, it's over the Netherlands, Denmark, and northern Germany. The high-pressure block in Eastern Europe breaks down as the storm advances. Freya loses power over land, but still brings heavy snow to Norway and Sweden. By December 6th, its remnants reach western Russia. What began off Ireland's coast has traveled thousands of kilometers, affecting millions. The storm's energy doesn't vanish, it's transferred into the atmosphere. As Freya weakens, It sends a pulse of energy downstream in the jet stream, like ripples from a stone in water. This pulse can help form new weather patterns over the Pacific. A storm in the Atlantic can spark a new system on the other side of the world. The atmosphere has a long memory. Energy from major storms can influence weather a week later, halfway around the globe. Storm Freya's journey is a global story of interconnected weather. Now, let's look at southern Europe's mild weather. The Alps act as a wall, cold air to the north, warm African air to the south. This contrast creates foehn winds. As air rises over the Alps, it dries, then descends warm and dry into Austria and southern Germany, causing rapid snowmelt. This pocket of warmth moves east, guided by the jet stream. Over days, it travels across the Balkans, the Black Sea, and into Central Asia. A farmer in Kazakhstan might see a rare December thaw, warmth that began in the Mediterranean. In the Caucasus or Tian Shan, sudden warmth can trigger avalanches or flooding from early snowmelt. The displaced cold air must go somewhere, perhaps deeper into Siberia, or south into China or India, causing cold snaps. A warm day in Rome can contribute to a cold night in Shanghai a week later. The atmosphere is always balancing itself. Moving one piece forces others to adjust. Weather is rarely local. It's imported, exported, and shared. The Alps to Asia connection is just one example of global atmospheric circulation. Europe's weather patterns directly impact North America thanks to the jet stream. The deep trough over the Atlantic that created Storm Freya is mirrored by a ridge over Europe and a trough over eastern North America. On December 3rd, this setup pulls Arctic air south, causing a cold snap in cities like Toronto, Boston, and Washington, D.C. The continents are locked in a weather dance. What happens in Europe often echoes in North America. This connection works both ways. Changes in North America's pattern will ripple back to Europe in days. Forecasters watch these patterns closely, knowing today's U.S. weather hints at Europe's next week. These links are crucial for industries. Energy companies, farmers, and airlines all depend on understanding transatlantic weather. The jet stream can speed up or slow down flights, and weather on one continent can affect the economy of another. The Atlantic is not a barrier, but a bridge for weather. Our fates are intertwined. Understanding global weather connections is vital for safety, economy, and future planning. Predicting how patterns travel lets us prepare. Coastal defenses, shipping warnings, and crop protection all depend on early forecasts. Farmers in Ukraine or coffee growers in Central America rely on global weather models to adapt to changing conditions. As the climate warms, these connections grow more important. A shifting jet stream may bring more extreme, persistent weather, longer heat waves, cold snaps, or floods. Grasping these links is the first step to predicting and mitigating climate impacts. Realizing our shared atmosphere fosters responsibility. Pollution or emissions in one region can trigger droughts or storms in another. The weather on December 3rd is a snapshot of this system, a reminder that local actions have global consequences. Facing these challenges requires global cooperation. We've journeyed across the globe, starting from a single day's weather in Europe. A storm over the Atlantic is a link in a global chain, not an isolated event. Jet streams carry weather from continent to continent. Pressure seesaws dictate winters for millions. December 3rd, 2025 shows weather as a narrative. Past, present, and future intertwined. Understanding these connections lets us anticipate, prepare, and protect. We are not separate from nature, but part of its grand rhythms. The air in London is part of the same system that brings monsoons to India or blizzards to Siberia. Next time you check the weather, think of the great dance of the atmosphere. The rain on your window may have started its journey on another continent. We are all citizens of one planet, living under one sky. Our fates and our weather are inextricably linked.